On the 8th of August, 2026, at 9 in the evening local time, the ground moved outside Denali National Park in Alaska. A magnitude 5.6 earthquake tore through the wilderness 35 miles northwest of a small town called Squenta. The United States Geological Survey confirmed the depth at around 6 miles. In Anchorage and Hope and Kenai, people felt their houses shudder. Nobody died. Nothing collapsed. But it was, according to meteorologists tracking the event, just the latest tremor in what has been an unusually active stretch for one of the most feared geological features on the planet. 3 days later, on the other side of the globe, the Earth broke again, this time in Colombia, with a force more than 100 times greater. And within the same week, scientists working independently in 3 different countries were being asked the same question by worried residents. Is the Ring of Fire waking up? And if it is, where does it strike next? This is not a simple story, and it does not have a simple answer. What we are going to do in the next several minutes is walk through exactly what has happened, what scientists are actually saying, as opposed to what headlines are implying, and where the real documented risk sits right now, according to named researchers, government seismic agencies, and the geological record itself. Let's start with what the Ring of Fire actually is, because the term gets thrown around constantly without much explanation. According to the United States Geological Survey, the Ring of Fire is not a single fault line and not a mystical belt of doom. It is the name given to a roughly 40,000-kilometer horseshoe-shaped zone that traces the edges of the Pacific Ocean, running from the southern tip of South America, up through Central America and Mexico, along the west coast of the United States and Canada, across the Aleutian Islands of Alaska, down through Kamchatka in Japan, through the Philippines and Indonesia, and finally to New Zealand. It exists because this is where the Pacific tectonic plate grinds against a ring of surrounding plates, some sliding past each other, some colliding, and in many places, one plate sinking directly beneath another in a process geologists call subduction. That process is the reason roughly 90% of the world's earthquakes and about 75% of the world's active volcanoes, 452 of them according to the USGS, sit inside this single geological neighborhood. More than 25 nations have territory directly on the Ring of Fire. That is billions of people living, working, and raising families on some of the most geologically restless ground on Earth. So when several large earthquakes strike in quick succession anywhere along that ring, it is completely understandable that people start to wonder whether something bigger is building. This is also not a new question. Back in 2018, the BBC reported on a strikingly similar cluster of events, when tens of thousands of people had their lives disrupted within a single week by seismic and volcanic activity spread across the Ring of Fire. A magnitude 7.9 earthquake struck off the coast of Alaska, briefly triggering a tsunami warning for coastal Alaska and British Columbia. On the very same day, an avalanche, possibly triggered by a volcanic eruption, killed 1 soldier and injured at least 11 others in central Japan, as Mount Moto Shirane, part of the Kusatsu Shirane volcanic complex, sent rocks raining across a kilometer-wide area. Around the same period, a volcano was actively erupting in the Philippines, and thousands of residents had already fled Kadovar Island in Papua New Guinea because of volcanic activity there. The United Nations Office for Disaster Risk Reduction posted publicly at the time that the Ring of Fire was, in their words, active. And yet, according to the same BBC reporting, the scientific consensus that emerged was that this level of clustered activity, while dramatic to witness, fell within the normal statistical range of what this region produces regularly, given how many separate fault systems and volcanic arcs are packed into it. The pattern we're watching unfold now, in other words, has a documented precedent, and it did not resolve into the kind of coordinated mega-catastrophe that headlines at the time speculated about. That history matters because it shows that public alarm about the Ring of Fire activating tends to spike every time several quakes cluster in the news cycle, regardless of whether those quakes are actually connected. Separating the recurring pattern from the specific documented risk is exactly what serious seismology tries to do, and it's exactly what we're going to keep doing for the rest of this account. To understand why scientists are being asked this question right now, we have to go back just over a year, to the 29th and 30th of July, 2025. That is when one of the most powerful earthquakes ever instrumentally recorded struck off Russia's Kamchatka Peninsula, roughly 74 miles southeast of the city of Petropavlovsk-Kamchatsky. The United States Geological Survey measured it first at magnitude 8, then revised it upward to 8.7, and finally to 8.8, making it, according to the USGS, the 6th largest earthquake ever recorded on modern instruments. The quake struck at a shallow depth of about 20.7 kilometers, which is part of why it was so destructive at the surface and why it generated such a massive tsunami. Within minutes, according to Reuters, a wall of water as tall as 13 feet struck the Russian coastline. Video footage circulating at the time showed the tsunami tearing through the port town of Severokurilsk, a community of around 2,000 people. Russia's emergencies ministry confirmed that the town flooded and that the population was evacuated. Remarkably, no fatalities were confirmed in the immediate aftermath, though the scale of destruction to infrastructure was significant. The United States Tsunami Warning System issued warnings and advisories that stretched across the entire Pacific Basin, for Russia, for Japan, for Alaska, for the U.S. Pacific Coast, and for Hawaii. The Japan Meteorological Agency issued its own warning, and CNN reported that up to 1.9 million people in Japan were told to evacuate coastal areas as waves of up to 10 feet were expected to make landfall. In Honolulu, sirens sounded across the city, and residents and tourists moved to higher ground, as the Pacific Tsunami Warning Center warned hazardous waves could arrive by 7 in the evening local time. What is striking, looking back, is how far early warning infrastructure has advanced. Despite the sheer size of the quake, tied for 6th strongest ever recorded, CNN reported that the destructive tsunami many feared did not fully materialize across most of the Pacific. And within 24 hours, most of the tsunami alerts around the world had already been lifted. Millions of people who had been told to run for high ground were able to stand down. That does not mean the danger wasn't real. It means the warning systems worked. But Kamchatka was not finished. Just days later, on the 3rd of August, 2025, a magnitude 6.8 earthquake struck Russia's Kuril Islands, triggering another tsunami warning for parts of the Kamchatka Peninsula, though the Pacific Tsunami Warning Center confirmed there was no threat to Hawaii this time. And in an extraordinary coincidence that seismologists are still studying, just hours before that 6.8 aftershock, the Krasheninnikov volcano in Kamchatka erupted for the first time in 600 years. Olga Garina, who heads the Kamchatka Volcanic Eruption Response Team, said publicly that the eruption may be linked to the earlier magnitude 8.8 earthquake. Then, on the 19th of September 2025, the region was struck again, this time by a magnitude 7.8 earthquake, which the USGS later confirmed was actually an aftershock of the original July quake, and its largest aftershock to date. Scientific American reported that officials at the Pacific Tsunami Warning Center ultimately issued an all-clear for Hawaii on that occasion, ruling out a Pacific-wide tsunami, since the July earthquake had already released more than 30 times the energy of this new one. Here is where the story gets genuinely unsettling, and where we need to be careful to separate documented fact from coincidence. Years before any of this happened, researchers named Kopnichev and Sokolova published an analysis of earthquake activity around the Kamchatka Peninsula, stretching from 1973 through late 2024. Their study identified what they called ring-shaped seismicity structures at different depths beneath the region, and they noted a historical pattern that large earthquakes tend to follow roughly 10 to 15 years after a sudden spike in seismic activity around these ring structures. Based on that pattern, and citing an earlier ring event that had shown a similar spike back in 2016, the researchers projected a likelihood of a large earthquake striking somewhere between 2026 and 2031, with an estimated magnitude between 8.4 and 8.8. According to the published record, a magnitude 8.8 earthquake occurred within about a week of that projection becoming public. Now, to be clear, this is a single academic paper, and forecasting the eventual location of a large earthquake within a 5-year window and a wide magnitude range is a very different thing from predicting an exact date. Scientists themselves are consistently blunt about what they can and cannot do here, and we're going to get to that. Alaska itself sits on one of the most seismically active stretches of the entire Ring of Fire, and the August 2026 quake near Denali was, in that sense, unremarkable in isolation. Fox Weather's own reporting on the event noted that while people tend to think of earthquakes as a Western United States problem, some of the largest earthquakes ever recorded in American history have actually struck the eastern parts of the country too. A reminder that seismic risk doesn't map neatly onto the assumptions most people carry. What makes the Alaska quake worth mentioning here isn't its size. A magnitude 5.6 is a moderate event that causes shaking but rarely serious damage. It's the fact that it landed inside the same compressed window as the far larger Colombia earthquake, which is precisely the kind of clustering that keeps prompting the "is the Ring of Fire connected?" question in the first place, even when, as we've already heard directly from Colombia's Geological Service and the USGS, the geological evidence doesn't support a causal link between the two. Even the tsunami itself became a subject of new scientific discovery. According to the Seismological Society of America, published through Science Daily, NASA and the French Space Agency, CNES's SWAT satellite captured an unprecedented high-resolution view of the Kamchatka tsunami as it crossed the Pacific, data that revealed the waves behaved in ways researchers had not fully expected, giving scientists a rare, detailed picture of how a megatsunami actually propagates across open ocean. That research was published in the journal The Seismic Record in 2025, and highlighted again by the Seismological Society of America in June 2026, showing that the Kamchatka event is still actively reshaping how scientists model tsunami behavior more than a year later. Now, let's move forward into 2026 itself, because this is where the pattern that has people asking questions really starts to take shape. On the 20th of April 2026, a powerful earthquake struck off the Sanriku coast of Japan, in the Tohoku region. The USGS measured it at magnitude 7.4 to 7.5, with Japan's own meteorological agency initially placing it even higher before revising the figure down. The quake occurred at a depth of 35 kilometers along the Japan Trench, a thrust fault, and generated a tsunami measured at 80 centimeters. 233 structures were damaged, and tremors were felt from Hokkaido all the way to Aichi Prefecture, hundreds of kilometers away. Records show the event was preceded by a magnitude 6.8 foreshock back in November 2025, and it produced its own aftershocks reaching magnitude 5.6. In total, the seismic record around the April rupture logged more than 160 separate foreshocks of magnitude 4 or greater in the months leading up to the main shock, the kind of extended buildup that, after the fact, seismologists can point to as part of a recognizable stress loading sequence, even though in the moment no one was able to say with confidence that the larger quake was imminent. That gap between what a seismic sequence looks like in hindsight and what it looks like while it's still unfolding is one of the central humbling limitations facing every scientist working on Ring of Fire hazard, forecasting today from Kamchatka to Sanriku to Cascadia. Less than 2 months later, on the 7th of June 2026, the Pacific's coordinated warning system was tested again, this time off Mindanao in the southern Philippines. According to the Intergovernmental Oceanographic Commission of UNESCO, a strong earthquake there put several countries on alert within minutes. Just 6 minutes after the quake, the Pacific Tsunami Warning Center issued its first threat message, warning of possible hazardous waves across Indonesia, the Philippines, Palau, Yap, Taiwan, and Papua New Guinea, based on an initial magnitude estimate of 8.2. As more data came in, the forecast was scaled back to waves of 1 to 3 meters for parts of the Philippine coast and up to 1 meter for parts of Indonesia and Malaysia. The earthquake itself caused significant loss of life, primarily from collapsed buildings and landslides triggered by the shaking, according to the IOC's own report. But officials noted that the rapid, coordinated early warning response likely prevented additional casualties along the coastline, a sharp contrast to the devastating Moro Gulf tsunami of 1976, which killed between 5,000 and 8,000 people in that same general region before modern warning systems existed. Later that same month, in June 2026, earthquakes struck northern Venezuela, damaging buildings in Catia la Mar in La Guaira state and causing a building to collapse in Caracas, according to reporting and imagery reviewed by Fox Weather. And then, as we opened with, came the first 2 weeks of August 2026, the magnitude 7.4 earthquake in Colombia on the 11th, centered near the town of San Jose del Palmar in the Choco region, felt as far away as Ecuador and Venezuela, followed by strong aftershocks that seismological agencies were still analyzing days later, and the magnitude 5.6 earthquake near Denali in Alaska on the 8th. So, 6 significant seismic events stretched across 13 months, touching Russia, Japan, the Philippines, Venezuela, Colombia, and the United States, all sitting somewhere along or near the edges of the Ring of Fire. It is easy to see why people are connecting the dots and asking whether this is one continuous, escalating chain reaction. Here is where we need to slow down and listen very carefully to what the actual scientists studying this are saying, because their answer complicates the dramatic version of the story, and complicating the story is part of being honest with you. After the Colombia earthquake in August 2026, Colombia's own geological service was blunt in its public statement, and outlets including Mexico News Daily and Heraldo USA reported it clearly. This earthquake was not, in their assessment, a scientific warning that any other specific country was next. The quake was linked principally to the interaction of the Nazca and South American tectonic plates in that specific region, a completely different plate system than the one driving activity in, say, Mexico, where the Cocos Plate pushing beneath the North American plate is the dominant hazard, with the Rivera Plate playing a secondary role. Mexico News. Daly explained the geology plainly. Plates are always moving, always accumulating and releasing stress along separate faults at different depths, independently of one another. A string of earthquakes across Latin America, they reported, does not mean the Ring of Fire has somehow been switched on as a single connected system. The United States Geological Survey backs this up directly in its own public guidance. According to the USGS, there is no definitive evidence that an eruption at one volcano can trigger an eruption at another volcano hundreds or thousands of kilometers away, let alone on a different continent. Scientists do know about something called dynamic triggering, where seismic waves from a very large earthquake can sometimes disturb fault systems that are already close to their breaking point, even at some distance from the original epicenter. But according to Mexico News Daily's reporting on this exact phenomenon following the Colombia quake, that possibility does not translate into an ability to forecast a destructive earthquake somewhere else on the ring. It is a mechanism scientists watch for. It is not a domino line they can predict in advance. Geraldo USA, reporting on the same question in the wake of the Colombia earthquake, put the core scientific limitation about as plainly as it can be put. It is currently not possible to predict exactly when an earthquake will occur. Scientists can study faults. They can analyze recorded ground movement. They can monitor tectonic stress. But they cannot pinpoint the date and time of the next major earthquake anywhere on Earth, ring of fire or otherwise. What concerns seismologists is not any single quake, but the slow, invisible accumulation of strain energy along fault lines that have gone quiet for a long time. Energy that has to be released eventually, sometimes catastrophically, and sometimes in ways too small to notice. As something of an illustration of just how constant this activity really is, Colombia alone records around 2,500 earthquakes every month. An average of roughly 80 tremors a day, the overwhelming majority of them too weak for anyone to feel. The August earthquake near San Jose del Palmar was, by Colombia's Geological Service's own account, the strongest the country had recorded in recent memory, and its aftershocks kept regional seismologists occupied for days afterward, continually updating magnitude estimates as more data came in from monitoring stations across Choco, Ecuador, and Venezuela. Efforts to actually forecast earthquakes before they happen are not new either. And it's worth noting how much investment has already gone into trying. Years ago, Fox News reported on an ambitious Chinese project in Sichuan and Yunnan provinces, two of the most earthquake-prone regions in the country, where scientists were building an underground monitoring network of up to 2,000 sensor stations. According to Wang Tun, the project's lead scientist, speaking to the Global Times, the system was designed to detect stress and energy dynamics between 4 and 12 miles underground, in the exact zone where most destructive earthquakes originate, with the stated goal of producing public forecasts for earthquakes of magnitude 5 and above up to 3 weeks in advance. The first monitoring station in that network was installed at the Yingxiu earthquake station, at the site of the devastating 2008 Sichuan earthquake that killed nearly 70,000 people. Even a system that ambitious was designed to produce probability windows measured in weeks, not exact predictions, underscoring again just how far current science remains from being able to name an exact date for the next major rupture anywhere on the Ring of Fire, including Cascadia. So if the Ring of Fire isn't one connected chain of dominoes falling in sequence, where is the genuine scientifically documented concern right now? This is where the story turns toward the United States West Coast and toward a fault system that has been unusually, almost eerily quiet. The Cascadia Subduction Zone runs for more than 600 miles, from Northern California up through Oregon and Washington and into British Columbia, marking the point where the Juan de Fuca Plate is being forced beneath the North American Plate. According to the University of Washington, this fault system is unusually quiet for a megathrust zone of its size. While most subduction zones produce a steady rumble of smaller earthquakes as the plates grind past each other, Cascadia has stayed largely silent, which has long fueled the working assumption that the two plates are locked together by friction, quietly building up stress with nowhere to go. The last time this fault ruptured fully was in the year 1700, according to research cited by Oregon's own Department of Emergency Management, meaning the region is now more than 300 years into a stress-building cycle that history suggests will not last forever. In May of 2026, an updated report from the United States Geological Survey raised the estimated probability of a magnitude 9 earthquake striking the full Cascadia Subduction Zone to 15% within the next 50 years, according to reporting from Colombia One that reviewed the study. That same USGS analysis found that even short of a full-scale magnitude 9 rupture, the probability of a magnitude 8 or greater earthquake in just the southern segment of the fault rises as high as 30% within that same 50-year window. The report noted that the Cascadia Zone has produced at least 19 major earthquakes over the past 10,000 years, establishing a clear, cyclical, geologically documented pattern of large ruptures. Other researchers cited in the same reporting put related probability estimates even higher for partial ruptures, a range of 37 to 43% chance of a magnitude 8 to 8.6 event limited to the southern segment within 50 years, and a 16 to 22% chance of a full margin rupture reaching magnitude 8.7 to 9.2, according to figures reported by the National Association of Counties. The Federal Emergency Management Agency estimates that a full magnitude 9 earthquake on this fault would kill an estimated 14,000 people across Oregon and Washington alone, and would be followed by a tsunami potentially reaching 100 feet in height in the most exposed coastal areas, permanently reshaping floodplains for generations. New research is also complicating the picture of how a Cascadia rupture might actually unfold. In February of 2026, University of Washington researchers published findings described by UW News showing that the fault is not as fully locked as long assumed. Their study, pulling data from underwater observation sites, found complex fluid dynamics deep in the subduction zone that may influence how the fault behaves when it eventually breaks. Co-author William Wilcock, a University of Washington professor of oceanography involved in a $10.6 million underwater observatory project, said the discovery suggests there may be more happening beneath Cascadia than scientists have previously been able to detect, and that more instrumentation is needed to understand it. Separately, in January 2026, scientists reported they were uncovering a hidden, previously unmapped earthquake zone beneath Northern California by tracking swarms of tiny earthquakes far too weak for anyone to feel, a discovery covered by Science Daily that adds yet another layer of complexity to the regional hazard picture. And in a study highlighted in May 2026, also through Science Daily, researchers found new evidence that the Cascadia Subduction Zone and the San Andreas Fault to its south may be capable of what scientists describe as synchronizing, triggering earthquakes on both fault systems within minutes or hours of each other, a scenario that could dramatically escalate the scale of damage across the entire West Coast if it ever occurred. That same body of research builds on an earlier discovery, reported in October 2025, in which a research ship's navigational error during a sediment coring expedition led scientists to uncover paired sediment layers, suggesting that past Cascadia megaquakes may have gone on to trigger ruptures on the San Andreas Fault as well. None of this constitutes a prediction of a specific earthquake on a specific date. It constitutes something scientists consider far more useful and far more honest. A documented, published, peer-reviewed picture of rising long-term risk, built from paleoseismic records, underwater observatories, satellite data, and ordinary seismic monitoring, the same categories of evidence that informed Kamchatka's ring-shaped seismicity research before that region's own megaquake. The Cascadia Region Earthquake Science Center, known as Crescent, was formed specifically to coordinate this kind of research, headquartered in Eugene, Oregon, and directed by geoscientist Diego Melgar, bringing together universities, government agencies, and nonprofits to study exactly these questions on an ongoing basis. Seattle and Portland, by contrast, still contain thousands of unreinforced masonry buildings, older brick and stone structures that were never retrofitted to survive strong shaking, and which engineers widely regard as among the most dangerous building types in any major earthquake. State authorities in both Oregon and Washington are actively using the updated USGS probability figures to revise vulnerability assessments for their most densely populated metropolitan areas, according to Colombia One's reporting, even as officials acknowledge that comprehensive infrastructure strengthening across the whole region remains a slow, expensive, multi-decade undertaking. Academic institutions involved in that work continue to stress the same point again and again. Raising a 50-year probability estimate is not the same as issuing a warning for next month, and the value of this research lies in guiding where reinforcement money and emergency planning get prioritized now, long before any rupture occurs. It's worth pausing here to be transparent about the limits of what can responsibly be said. Away from established institutions like the USGS, Crescent, and peer-reviewed academic journals, there is no shortage of amateur forecasting websites and social media accounts that claim to predict the exact month or even the exact week a major Cascadia earthquake will strike, sometimes citing their own private mathematical models. These claims are not backed by the USGS, by any named seismologist at a research university, or by any peer-reviewed publication, and responsible reporting on this topic treats them as unverified speculation rather than science. The honest scientific position, repeated consistently by the researchers and agencies named throughout this account, is the one Geraldo USA's reporting captured plainly. Nobody currently has the ability to predict the date of a major earthquake anywhere in the world, Cascadia included. What scientists can do is measure risk, track probability, and improve the speed and accuracy of warning systems for when a rupture does occur, which is precisely what happened during the Kamchatka event, when early alerts likely prevented a far higher death toll, and again during the Mindanao earthquake in June 2026, when the Pacific Tsunami Warning Center issued its first threat message within 6 minutes of the initial shaking. So, to bring this together honestly, the core verified facts are these. The Ring of Fire has seen an unusually active stretch of large earthquakes between July 2025 and August 2026, from Kamchatka to Sanriku to Mindanao to Caracas to Choco to Denali. These events are confirmed by the United States Geological Survey, Russia's own Geophysical Service, Japan's Meteorological Agency, Colombia's Geological Service, and the Pacific Tsunami Warning Center, along with reporting from Reuters, CNN, the Associated Press wire network reflected across regional outlets, Fox Weather, Scientific American, and the Intergovernmental Oceanographic Commission of UNESCO. What is not verified, and what named scientists at these same institutions have explicitly pushed back against, is the idea that these earthquakes are causally connected as a single chain reaction sweeping around the Pacific. The USGS states directly that there is no definitive evidence eruptions or major quakes trigger events far away on a different part of the ring. What is separately and independently documented through USGS reports, University of Washington research, and FEMA risk assessments is that the Cascadia Subduction Zone along the United States west coast carries a real, rising, scientifically measured probability of a major rupture within the coming decades, a genuinely different kind of warning than the ring of fire is coming for you next, and one grounded in 50-year statistical windows rather than any specific date. The Kopnichev and Sokolova study on Kamchatka's ring-shaped seismicity structures remains a single academic paper whose timing lined up with the 2025 megaquake. And while that is a striking data point, one paper is not scientific consensus, and researchers themselves would be the first to caution against treating it as a confirmed predictive method for other regions like Cascadia. What we're left with, then, is not a countdown clock. It's a slower, more sobering reality that the Pacific Ring of Fire is doing what it has always done, releasing stress unevenly across a horseshoe of fault lines that circle a third of the planet, and that the regions carrying the most serious, best documented long-term risk right now, according to the scientists and agencies actually studying it, are not necessarily the ones making headlines this month, but the quiet ones, like Cascadia, where the silence itself is part of what worries researchers most. So here's the honest question worth sitting with. Given everything we now know, that scientists can measure rising risk decades out, but still cannot tell us the day or the year an earthquake will strike, and that regions like the Cascadia coast have gone quiet for over 300 years, while the pressure beneath them keeps building, do you think enough is being done in your own region, or the ones you've heard about here, to prepare for an event scientists agree is coming, just not when? Let us know what you think. It's worth remembering, too, just how much has changed in the ability to respond once the ground actually does move. Compare the Moro Gulf tsunami of 1976, which killed between 5,000 and 8,000 people across southern Mindanao with essentially no advance warning, to the June 2026 earthquake in that same general region, where the Pacific Tsunami Warning Center had a threat message out within 6 minutes. Compare the near total absence of coordinated alert infrastructure in past decades to the layered system that stood down tsunami warnings across Japan, Hawaii, and the U.S. West Coast within 24 hours of the Kamchatka megaquake in 2025, even after evacuating over 1 million people. The science of predicting exactly when an earthquake will strike has not meaningfully advanced in the way many people assume it has, but the science of detecting an earthquake the instant it happens and getting a warning to the people in its path within minutes has advanced enormously. And that gap between prediction and detection is arguably the single most important distinction in this entire story. Prediction remains, by every named scientist and agency in this account, essentially impossible today. Detection and rapid warning are not just possible, they are actively saving lives across the ring of fire right now, quake after quake, year after year. That's where the verified record stands as of this week. Thanks for spending this time working through it with us.